Hi everyone. So we are finally live. I see a lot of people joining. Looking forward to see people join as we go into this community call. So welcome everyone. Today I have Josiah Bryan here with me. He will be holding a talk on the topic of optimizing insulin management, the role of GraphRAG in patient care. Josiah, you can definitely unmute. I just wanted to say, do that while you might be drinking water and preparing for the talk.
Thank you very
welcome
much. It's
to
good
the
to be here.
community call.
Thank you. Excited to share with you guys what we're doing.
Yeah, nice to have you, definitely. So Josiah here is probably going to tell you more about himself, but as a small intro, he is the CDO at Precina Health, which he's going to talk about more. Today I will give just a short intro to the topic because there are a lot of terms that you're going to hear about, and I kind of feel that it will be good we go through them just to have a better understanding of everything that's happening. And then I'll give the stage to Josiah. So yeah, let me start first explaining a bit about RAG and GraphRAG. So first of all, I guess a lot of people who joined know what is LLM. If you are not sure, I guess you at least talk to ChatGPT. And the ChatGPT has a GPT in the background. It's also a large language model. And you basically are familiar with asking questions about who knows what. I know that people have tried to ask a lot of various questions there. But maybe you sometimes wanted to ask a question about some data that you have either personally or within your company. And then you might have faced an issue where, of course, LLM doesn't have that knowledge. It's your internal knowledge. So, for example, if you're a company that deals with medical records and you have like a lot of medical records and you want to ask a question such as which patients had similar symptoms to patient Mark and how were the treatments concluded? Well, to ask that to the LLM, you would have to provide all of the medical records to it so it can generate a response. Now, there are some limitations there. It would be awesome if you could just do that, and if it's not slow, expensive, and hard, and limited. But yeah, it is limited. So basically, LLMs have a context window. So each model has like a number of tokens, which can be a part of the context that is within the prompt. And this is the limitation that you have. And then, of course, like if you were to give it a context, you would say like, which part of my document should I bring attention to? And this is really hard because you want to know everything from your document. So you cannot just give all medical records at one time. So to kind of give a solution to that, there are various strategies these days, and maybe the most mentioned ones are the retrieval augmented generation, or RAG. And the other way of doing that would be to fine-tune the model. Now, these are two different strategies. I actually heard people also combining them for different use cases, different parts of their applications. But to explain the difference in RAG, you would actually retrieve the relevant information from your documents. That amount would be the one that can fit in the additional context of the prompt. You would give that to the LLM, so LLM is aware of that knowledge, and LLM would then be able to generate the response. When fine-tuning the model, you would actually have to go through the learning process from the document. So actually train the LLM, that model would be improved. And then when you ask a prompt to this new model, you would also get a response. But of course, if patient Marks goes frequently to the doctor and it has a lot of new medical records showing up, then what to do with fine-tuning? You would have to retrain the model. You have new knowledge, like it needs new knowledge. So if you have changing data, I would say like it's easier maybe to use RAG. It's better maybe to use a RAG. It's more scalable, and as the knowledge grows, your system grows with it. So it's a bit of different approach, and that's why today we are going to talk more about this approach, RAG. So RAG is a way to make LLMs more accurate and personalized to your specific data. So if we were to go back to the initial prompt, and poor Mark, we don't want to say that only Mark has these issues, but let's stick with Mark. LLM doesn't know the answer to this one. But if we were to do a RAG, we would have to find the important parts. So like patients, similar symptoms, patient mark, treatments. We want to find these kind of keywords within those documents that would give us more information about mark. So the goal is to find and pick what is relevant. I know it's not definitely an easy task. It's easy to say it like this, but we will definitely Josiah will definitely go into more details about that. And then you append that relevant information in the prompt. It's enriched prompt, and LLM gives you an answer. And this actually involves two steps. So first of all, data source is, let's say, a lot of PDFs, a lot of text or whatever. So first you have to structure and model the data. And the second step is to find and extract relevant information. So to do the first step, there are like n different ways. And to do the second step, there is like n different ways. And how to decide which is the best one, I think this is all over the place now. And I think this is the reason why everyone is so maybe confused with the term of RAG, GraphRAG, hybrid RAG, and I think there will be like 100 more. So the goal of the first step, I would say, would be to optimize for step 2. So it definitely depends on what are you doing, how do you plan to find relevant information, how do you plan to extract it. And the goal of the second one would be to find the most relevant data, considering what you think is relevant data for your types of questions. And again, not too much, you still have the limitation of the LLMs. As said, n combinations on the left side, n combinations on the right side. And this is just an example of what you can use. So for example, to structure and model data, you can use in-memory structures, such as inverted index structure. You can use databases, such as Graph Database, of course. You can use engines. And on the right side, to find and extract relevant information, you can first use pivot search to find those data pivots by similarity from the prompt important words. And usually nowadays people are talking about vector search here, but there are different approaches as well. And then you can do relevance expansion, where you expand from data pivots. In there you get like relevant and connected information. For example, in graph databases, maybe like one hop neighbors or similar. You can do both, you can do one, you can combine, maybe do something third. It's definitely an open world. But you might have heard about Microsoft GraphRAG just because it's out there. So what it actually is, so it uses in-memory graph structure to do relevance expansion. It uses latent algorithm there. It's a community detection algorithm. And it uses vector database to do vector search for pivot search. So it's actually another combination of those things. They had a really good paper on this, so definitely go read it. But yeah, so to conclude, GraphRAG, we can say, there are a lot of definitions, is a RAG system that combines the strengths of knowledge graphs and large language models. And when talking about knowledge graphs, let's just get this straight. So it is a structured representation of information where entities and their relationships are organized to enable reasoning and insights. So you have a network of nodes and edges that are representing data and they don't have a layer of meaning or semantics, then you kind of lose that whole knowledge graph thing. And knowledge graphs are important for GraphRAG. And the strength of graphs is that you have relational context, improved retrieval accuracy, you have multi-hop reasoning, you have efficient information navigation. And why would you use a database? I say, okay, you can use graph structure, but why a database? Well, probably if you have dynamically evolving knowledge, you would want to have everything growing along with that knowledge. And database helps you here, especially in Memgraph in real time and with incremental graph algorithms. So to go back to the example, if we were to search for patient mark in a graph, we actually find a node which is mark, and then we expand from mark, like who are the neighbors of the mark, who is in the community with mark, and then that way we get the enriched prompt that we sent to the LLM. So if you were to ask, okay, but how will I build the GraphRAG with Memgraph? Well, you can use it in various ways. Josiah said he's going to talk about his way, but mostly nowadays it's used for relevance expansion. And to announce in the next version of Memgraph, we will be releasing vector search, where you can do with which you can do pivot search, and we will be releasing a latent algorithm as a better version than Louvian community detection. So this is kind of small announcement on our side. But yeah, I think that's it regarding my slides. I definitely invite all of you to participate in Josiah's presentation in a way that you can ask questions and I can jump in and ask them in real time. You can use the chat, you can use the questions in Livestorm, and there will be a couple of polls there as well. And I think this is really enough of me talking. So Josiah, the stage is yours. I will stop my sharing and you can go.
Thanks, Katrina. I'm just thrilled to be here. I'm honored to be here, thrilled to be here, and just any chance I get to share what we're doing with technology to help people. That's what really excites me about my career has been, is the intersection of people and technology. Not making technology for technology's sake, but how can it really help real people? Not to use the word real too much. So I'm currently CTO at a company, at a healthcare medical practice is the right term, called Precina Health. At Precina Health, we have solved type 2 diabetes. We have fixed type 2 diabetes. In type 2 diabetes, if you can decrease hemoglobin A1C by 1% in a year, you would have a medication worth $1 billion, insulin. These medications that can help you maintain control, decrease A1C. That's 1% in a year. At Precina, we decrease A1C by 1% per month. That is incredibly impactful. It lowers the cost of care dramatically for people. And we're doing it for rural and low-income patients, Medicare, Medicaid patients. And we help these people stay in control for years. Not just lower the cost, but they also feel better for the long haul. These results are happening in some of the toughest communities where healthcare has had the hardest time serving people. We did our initial research study in rural Louisiana with 50 patients. And out of those 50 patients, 49 of them have maintained and stayed in control of their insulin of their A1C for years. The one person that didn't disclose their medical issues at the start, we found an issue where they shouldn't have been in the trial in the first place. And since then, we've helped hundreds of thousands of patients. Now, technology isn't perfect. Technology has failed very publicly in insulin management, especially in the last 5 years. We've had some tech that's come to the market with some companies that promises to lower A1C by as much as 0.5 point in a year, or some even up to 1% a year, but they don't do it in ways that economically move the needle. To find ways to move the needle, we need to make it cost effective. Does our technology do that? No. Is it a catalyst for making that change? Yes. So what we've done is we've deconstructed the entire outpatient clinic experience, because we know there are 3.5 billion people with chronic disease. Today we can help with type 2 diabetes, and we're making inroads with cardiovascular and pulmonary disease. And I'd be happy to come back as in a year or two when we have more medically relevant results to share about those disease states and how we're using technology in that. But for the conversation today, let's talk about how Precina does it and how technology, specifically GraphRAG, is helping us do that. To explain how Precina helps and to explain how we're getting the technology, I want to tell you what we do and what we don't do. Over the last 40 years, there's many different ways to help with insulin. Clinical medical care, that's where the insulin part comes in. That's a known variable. Clinical behavioral care, and then what people call in the industry social determinants of health. That's like access to medical care, transportation, can you afford the medicine? And then there's other variables that people either aren't paying attention to or aren't even aware of. Over the past 40 years, clinical medical care has done great for certain people, but doesn't solve the problem, barely keeps it under control. Clinical behavioral care, well, that's like therapy, mental therapy, behavioral change therapy. That's great if you can afford it, if you have access to it, but the problem there is it's too expensive. And there's not enough behavioral care technicians available for people that need it. Social determinants of health, it's a being thought of in research papers and institutions, but it's these factors that are the social determinants of health. They're not easily accessible or changeable by the individuals, and the other variables, some people aren't aware of them or they're not able to implement them properly. And since Precina, what we've done, we started from the ground up and deconstructed the way we do a medical practice, and we've incorporated every one of these things into a unique model that we can implement effectively with every single patient. We're not just giving them medicine, we're not just treating the behavior, we're factoring in everything. It's a holistic experience. We combine all of these things together. Technology can't do this. Technology does not fix the problem. Technology is a catalyst for change. Technology is a catalyst to help the problem. It's a catalyst for providers. It's a catalyst to help patients. It helps administrative staff. What it's really about, the technology in this situation, it's about meeting each stakeholder precisely where they at to do precisely what they need it to do, not for the economic benefit, but for the benefit of the clinical outcome. How do we do that? We do it by making very small changes very quickly. Some people may be scared by, you tell them, eat right or start exercising, going to the gym every day. That's scary for some people. For me, I have trouble eating right sometimes. It's about making these small changes. So they might be scared by those things, but ask them how it feels to go to the mailbox every day. And then what you do is you want to check in and say, how far away is your mailbox? Did you do it every day? Explain it back to me. How do you feel? And it's exciting to see these changes pile up and then buy in to this. And the technology is a catalyst for all of these changes to enable this. Now, obviously, if you get the people involved in this, myself included, in a room, we're going to talk about the changes and what we're doing here in 24 hours straight without sleep. But to put a frame around today for the next 25 minutes or so, let's talk about GraphRAG and how that factors into Precina and what we're doing here. Precina, we use AI in, like I said, either 9 different deployments right now. 3 or 4 of them are in production right now, and 5 or 6 are on the R&D bench right now, either in getting vetted by our clinical team or about ready to be deployed in a few weeks. We call our overarching benchwork P3C, or the Precina Provider Patient Copilot. It's a mouthful, but we use graph knowledge and we extract it and store it in Memgraph to provide to our copilot both practical routines, so the procedural knowledge, the next best step. We reason through that using MCTS and POMTP, but we also use it to store the knowledge, the facts of the information. And I'll get into how we do that. I did see a great question, and I see Katrina already replied to some of that. Graph modeling, yes. Yes, please ask questions. So this is a screenshot here, and I'll actually show the actual thing of the graph we constructed and extracted from Memgraph Cipher Docs. I was talking with Katrina a couple of weeks ago about improving answering questions in Cipher, and since I couldn't get approval from my legal advisors to show real patient data or even my test patient data, I had to go with something a little bit more close to home, Cipher Docs, for our demos here. So the first part of actually doing any effective GraphRAG is to actually build the knowledge base. And I wanted to show how we're doing that. And I've got some windows open here. This is not the window I meant to show. Is that one? Holy cow, I have too much code open.
A lot of tabs.
Oh, so many tabs. If anybody doesn't use the context plugin for Mac, this is just a free tip. Use context. It makes this wonderful thing. Upserting. So first of all, we had to make an adapter to connect to Memgraph and connect on top of the Neo4j plugin. And we have a simple API on top of that upserts the nodes and edges. And that looks just like this. It creates this lovely little node relationship. That's not exactly the most exciting thing in the world, but it's practical. It's the root of where we're going. To do this, we build on top of a large benchwork of our base system. We've got a ORM that sits on top of a MySQL database. That MySQL database uses the ORM to manage the data. The ORM wraps individual classes with higher order wrappers. One of those higher order wrappers implements a vector index of the content. Individual classes use that wrapper, so it doesn't cover every single class. So we've got AI graph node definition. Yes, and the node manages things related to exactly what you would expect to be managed in a graph database. Although our database, our MySQL database, we do not use it as a graph database. We use it as a source of truth to upsert to Memgraph. But the important thing is that this same data that we upsert to Memgraph is also indexed in our vector database. In this case, we use QDRAND, but we also use, I forget the embedding model I'm using right now. It's a 768 vector. We don't use OpenAI's embeddings because we wanted to keep shorter embeddings, and OpenAI's Matryoshka embeddings, even at the smaller length, did not perform as well against this embedding model, which I should have had pulled up. I forget what it is. If anyone wants to know the embedding model, let me know. I can find it later. But the important part here is that we have the MySQL database as the grounding database, and I don't have that image that I showed you, Katrina. I should have thought of that too. Grounding database, and then we mirror it to the vector database and to Memgraph. That's the important part here to take away. Now, how we actually generate that, and this slide relevant, upserting data, yes. Data set to knowledge graph. What we do is we take raw unstructured data and we parse it and we extract it using GenAI, using the LLM. And my personal model of choice right now is GPT-4o Mini. We store things. That's the other part of it, is we have a model for data set. Data set has many data set items, any files you want, PDFs, et cetera, You can see I do a lot of testing. This is my personal code as well as the actual code that does the upserting. I won't belabor you with walking through the entire thing, but I will show you one part of it, which is the schema. So we do use this schema with function calls to extract a set of nodes that is validated, and then a set of edges. And if you're interested in how we're validating perplexity and probability, log probs, I've got a write-up on Dev 2 I can share. We extract the perplexity for each of the keys and values, and we can specify in the schema to enforce grounding against the source data to hopefully prevent hallucinations. An important part of this extraction that powers our knowledge graph is we use the LLM to also extract, alongside of the nodes and the edges, we extract an array of citations that we also validate algorithmically against the source text. I'll show you what that looks like in Memgraph here. So when we look at the extracted graph from the Cypher docs, actually, you know what? Lab is great. Let's look at the actual data set. That's not the window I want to show. That is still not the window I want to show. Well, that's the window I want to show. I have no clue what data set this is here. That's a PDF. Okay. The Memgraph Cypher docs here. So this is the graph that we extracted any day now, people.
So you basically took like the Cypher part from Memgraph documentation. Yes. You kind of store everything into the relational database, and then you created this additional layer of vector index, and you also created this data in Memgraph as a graph, right? Correct. So in Memgraph, the same graph exists. It's just not going to show the citations. It'll show the citations, the raw JSON. So I wanted to pull up the citations here and show you citations for one of the nodes. So here's the node for Cypher, and you can see it extracted it from many different locations along in the graph itself. Underneath the hood in the JSON, it stores the individual ID of the document it extracted that from. So we can pull up this node, find the documents it found it in, go back and reference that exact source chunk of text. And I won't belabor the point, but this is an example of the graph extracted. So this was all done with GPT-4o Mini.
using this upsert code to pull out the relationships, validate them, and then insert them into the graph. From there, we've got to, and I could run the code if you really wanted to, but I don't think that's a practical use of our time watching an LLM spit out nodes. And I've already covered the dataset graph view, which is what really excited to show you guys the node viewer, because this is an example of a generic data set. We can do that same extraction for many different things. One of the things that I have done to validate the research that I've been showing here today and will continue to work on is use the publicly available test data sets that are frequently used for RAG. One is and I mislabeled that hotpot QA, called a typo, Josiah. Hello, fix that. But hotpot is a great data set because it has hundreds of thousands of Q&A pairs. These are only the first 20, and they're all sourced from Wikipedia pages. And the unique thing about that is that they require multi-hop reasoning over more than one Wikipedia page extract. So it's an excellent use of context for GraphRAG. And you can see we've extracted a bunch of nodes from just whatever they have. So as far as to Sam's question about how we interrogate and examine the QC, the relationships made by GPT, that's a very good question. I don't necessarily do a lot of validation of relationships. What I do is provide an accepted list of relationships that my engineers or my advisors have said are good for use for knowledge graphs. And so we, without validating against the original source text, we validate is it one of the accepted relationships in our schema? B, is it, and it looks like that validation failed there. If it's low enough perplexity, we will accept it in the validator to get the relationship stored, but then we flag it for review later in an exceptions list with it. We have a prediction log list that flags exceptions. But by and large, they're validated. A are in the list, B is the perplexity under the acceptable value. Because the perplexity is a great indicator of how confident the LLM was in the value that it generated for that field. In this case, the relationship type field. Yeah, thank you for posting that, Marco. That's the link to the Hotpot QA site. That is perfect. Yeah, Nelson, the great question about stakeholders and how to derive actual meaning from the graph. And I struggled with the same thing when I first started working with graphs. Yeah, this is cool, and boy, wow, it's just fun to look at. But okay, what else? It's one thing to look at the graph and be amazed at the complexity that you see there, and to watch the pretty physics at work. And the Orb team has done a great job. This is built with the Orb viewer. Still waiting for it to hit 1.0. Can't wait for that. But as far as deriving meaning from that is largely where I'm focused on with the GraphRAG and the graph traversal algorithms that we're working on. And that is largely oriented around the Q&A type of an interaction with a graph. So asking questions of the data over a data set. Each graph that you're seeing here is contextualized to a specific data set. The data set can be whatever the consumer, whatever the user wants. You can see I've got a bunch of different test data sets that I use for various purposes. So contextualized to the data set enables the Q&A type of an interaction. And another way we're using it is for actionable insights over the data for agent planning. So extracting the next best action in the context of data. We build up graphs for actions for agents from knowledge from interactions with users and consumers of that. So it builds the agents as they interact with the patients. They'll build up relational graph knowledge of the person's personality. This is way rabbit trailing to the right. I'm sorry. Transactional analysis, therapeutic style of understanding the underlying things that people are thinking. We build up graphs of knowledge of our conclusions, hypotheses, and then we traverse those graphs, reinforcing the edges or pruning the edges as needed. And that goes to how are we extracting meaning from the graphs. The graphs themselves in those cases, aren't designed for necessarily human consumption. They're not meant to be looked at or used directly. In fact, most of the graphs that we're generating here, let's be real, they're not meant to be used by anybody except people like us who think they're cool. They're meant to be usable to extract other forms of information from. When I'm doing GraphRAG, nobody ever sees the graphs. They see the output from that. I'm happy to dive into that more. I realize I'm painting with a broad brush, but it's not, thank you, but it's not necessarily specific to any one use case. And now that my brain has gone completely off track, I'm going to go back to my slideshow that I can remember where I was going to go after this.
But it's definitely a great answer, as Nelson said.
Thank you. So as far as the actual method that I'm using for GraphRAG, and let me just pause for a second and share that. Sorry, I'm too many screens up here. I was worried that I wasn't showing you something. And Katrina's point is very, very accurate in that the whole challenge with RAG is identifying the chunks to feed to the LLM to generate the answer. Then we can always talk about how you validate the answer, how do you validate that it's being cited, all those things. Love talking about that too. Point being is that GraphRAG and any type of RAG, the real challenge is choosing the right thing to give to the LLM. And the GraphRAG has become this label that just encompasses so many different ways to do it. And I am not nearly arrogant enough, though my ex-girlfriend would say I'm very arrogant enough, but I'm not nearly arrogant enough to say that this is the one right way, or I found the best way to do it, or I found a unique way to do it. I found a way that works for my use case, and it works really well with Memgraph, and feel free to improve on it. So what we're doing with this is a two-stage extraction, and it's not, to set it apart from Microsoft's research, we're not using the pivot links. We're not using, if I remember correctly, they're doing it in a, they're doing it in not in a knowledge graph. They do present it as chunks with communities, with summaries, and then traversing over to do that reverse process to generate the RAG chunks. This is using the knowledge graph that you saw here. So it takes advantage of everything we said so far. So I'll walk you through this. Hopefully I won't bore you too deeply with it. But we take the user's raw query. For example, how do you group nodes in and get a count of nodes in Cypher? And I can actually show you how to generate that. Feeds it to an LLM to rewrite it into a hide query. The hide query, if you're not familiar with that term, I'm kind of misusing it properly, is it rewrites it in the query to resolve any code references, fill in any missing words. For example, if the conversation was talking about Cypher and grouping stuff, and the user's query was, how do I do that? We want to rewrite that code reference to incorporate the context from that. And then the important part is the second part, the hypothetical answer, embedding a hypothetical document. Lets the LLM take a stab at it from its intuition of what the potential answer could be. We don't use that answer, which is ungrounded. We don't use that for the user, but we do use that to guide the search process to help contextualize that, because, well, some nodes may be close to the user's query about a list, the answer may be about a grouping function. And so if the LLM from its intuition can add some semantic clues to the answer that get us closer to grouping as the concept versus list, that will help guide the search to a much more accurate and grounded chunk selection process. So that's key here. We take the hide query, the answer plus query pair, we embed it using the same embedding function we use for QD-RAN, whatever that model would be. And then remember, because our bench work does an excellent job of making these operations very transparent and generic, it has, at the time of generating these knowledge graphs, it's already embedded all the nodes and edges into the vector database. Now the key insight here is that we're not selecting nodes when we look at it. What we're doing when we're selecting the actual graph is we're asking it for the edges when we're doing the vector query. Because, and I'm sure this makes sense already to you intuitively, but I want to just put a pin on that, because if you're looking at any given node, the node itself doesn't have much context, nor does this node. But what gives you the true context is this edge here. So we embed the start, link, and end node plus the context as the embedding for that given edge. And that edge is what we're querying with vector database against the hide query. So what we get back is a list of edges. And as far as the selection process for the list of edges, there's two ways you can do this. And I've implemented both ways just to try and test and see which way works better. And one way is I would call the naive way, and one way is the MCT SPOMDP way. Both are right now within 2 or 3 percentage points of that, with about the same standard deviation as far as results on Hotbot. But I'm hoping and I'm believing that I can push MCTS further. So what I want to, thank you, Katrina, perfect. Let's just talk about the nodes for self. The initial response back gives us a set of edges that have a similarity score. And you could just take a flat threshold and say, which I've done, and say, here, give me only the nodes above this. These are the ones I want to consider. What I have found, though, is that often, much like our human brain, we ignore a lot of things that are just kind of, oh yeah, that's all the same. Oh, wait, that one thing stood out to me. I'm going to look at that. How do we get the machine to figure out what that one thing is that stands out? And that one is done with, if I can pull up the code quickly enough, something I call identify similar values. And it's really, yeah, there it is. Yay, I can actually do something quickly enough to show it. This is not a revolutionary technique, but it is a useful statistical technique. It calculates it based on z-scores and gap analysis where the values is. So take an array and a value, do gap analysis based on z-score. Z-score is the standard deviation away from the mean, and then group them by the differentiation. So what that ends up doing is if I have 5 edges that come back and each of the edges are hovering around 5, 5, 5, 2, 5, 3 similarity, 0.52, and then one edge happens to be about 6.6 similarity, well, that's obviously an outlier to you and me looking at the data. We intuitively know that. Finding a heuristic that does that proved challenging for me until I hit upon the z-score and gap analysis, which required my brain painfully to go back to college statistics, which I loathed. But it's here and it works. So my point being is that's how we select the relevant edges, either for MCTS expansion or for naive one-hop neighbor expansion. In this graphic, we're talking about the one-hop neighbors, which we do with Memgraph, and also the MCTS is done with Memgraph. But here, and that's just to get through the rest of this, and I can talk more about MCTS. So we take the relevant edges, we ask Memgraph, hey, what's the neighbors for the start and the end? That gives us an expanded pair of edges, and I do not have that on my screen here. Oh, I do. Yeah, look at me. Nope, that's not the thing either. Doesn't matter. I wanted to show you that generating. Expands the list of edges, sometimes about 100, 140 edges. And then we extract those citations. Remember I told you about citations. We extract the dataset item, the text. We make that unique as far as the unique dataset items. We extract unique chunks. And then we go back and ask QD-RANT, hey, which of these dataset items looks relevant for the hypothetical answer? Not which of it looks close to the edges, but then we ask it for it to identify similar chunks. That's, again, getting that similarity down. And then from there, it's just a matter of answering with an LLM. Answering with an LLM is the key thing here. And Katrina, I've lost my overlay that was showing slides, so I'm hoping that you've got that up there. That was showing the chat.
Which one?
Nope, I found it now. My chat over here I didn't have, so sorry about that. Okay. So this is how we're doing the Memgraph. The unique part of this really is using hide, getting the edges, selecting the edges, and then getting other edges, and I'll talk about that in a second, then going back. Once you have your set of edges, like, hey, this is where we think the answer would be, you've selected those edges, then it's a pretty kind of obvious way of going back down the stack, getting that into the LM, answering. The one fun thing that I do for our use case is asking a 2-stage citation. I experimented back in the day, as in a few months ago, with just having the LM generate a JSON blob that had a string of the answer and then an array of citations. That delayed latency, increased latency, delayed responsiveness, because it's hard to stream out the JSON chunk by chunk to the UI. B, it also led to some hallucinations or not getting all the citations accurate. So instead, in the latest iterations I've been doing, and I've seen this very effective, Salesforce does a similar thing. We use Salesforce in our practice. They'll generates the answer first using streamed chunk mode from the LLM. We streamed it immediately to the client, tell it the answer, and then we run a second LLM while the user's reading that. And we give the second LLM, again, probably GPT-4 Mini, the text we generated, the context that we selected, and ask it to select the citations from the text. So basically pairing what it said, saying these sentences that I said match up to this data set item here. And then we feed that as a JSON array to the browser for displaying the grounding. And so that all is given to the user. That is, in a sense, the GraphRAG that I've implemented here and that we use today in our practice for question and answer inside of P3 Copilot, P3C Copilot. And that alone shows incredible results, like I said, on our GraphRAG with the Hotpot QA. To get even just a few points better, I've gone through and implemented Monte Carlo tree search along with POMDP. And I'll just pause that nobody is asking more questions. Good, okay. So just to tell you about MCTS.
Can I just ask one question until you hop on that topic? Because you mentioned a really cool point there. You said like, this works in my use case. This works great for me, and you have been using it for a lot of things. So this whole, your idea of how to build this GraphRAG, like, what do you think for what kind of use cases this is good? And do you know of use cases that this wouldn't be good for? Do you have any idea, or do you kind of, is the goal to get it great for any type of use case? Like, what do you think?
Great question. This is the one that stands out immediately to me as this is horrible for, is long context generation over multiple long documents. For example, we had to write an IRB, which an Institutional Research Board study request. Sorry, don't quote me, I can't remember my medical terms, but it basically is a multi-100-page document apparently. And part of that was I was taking existing IRBs, existing studies, existing research papers under the guidance of my CEO and mentor. And he would say, we need this section of the IRB written out. And he said, use these papers. Here's a question I'm going to ask. Generate me a 2-page draft, and I'll go back through and edit, review, and revise it, he said. And it was really difficult. That was right when Claude Opus came out, Claude 2 Opus, whatever the Opus. And I had just developed what I called MapReduce Reg, and which is exactly what it sounds like. I won't bore you with the details. But the point is that it was not very good at identifying the relevant chunks for every section that it needed to generate, because it was a large thing in, large thing out. This type of a reg and reg in general, as well as GraphRAG, well, GraphRAG is trending the other direction, but reg in general would require a larger orchestration system to really achieve that use case well. What I mean is, like, generate multiple chunks, run reg for each chunk, make sure that maybe have an outline to generate those things. So that is not good for the long context generation where it's a large in, large out type of thing. With GraphRAG though, and with a proper orchestration or an agent on top of that, like the Monte Carlo tree search type of an agent, where it's not just using MCTS for the knowledge, but also for the action planning, would it probably enable that better? And that's an active area of my research, is using MCTS with graphs for action planning and making that better. Does that make sense? Or did I lose you halfway through?
No, definitely. Especially the example where you said it doesn't work. It makes sense.
And I do see a question, optimizing insulin management. How does this relate to that? I must confess, the marketing department might have taken my words and made it sound a little bit more exciting than it actually is, because I'm not legally allowed to practice medicine, full stop. And neither is my technology. So when you read the English words, optimizing insulin management, it might mislead you to think that the AI is doing some sort of linear regression, or it is tweaking the prescription up and down, or we're using the graph to change the values that the person's taking. None of that is true. 100% full stop. We do not touch the prescription ever. What it does do is optimize the management of your patient, manages the interaction, optimizes the interaction. Ways that we're using to optimize insulin management really comes down to the high touch environment that we're operating with patients. For example, specifically, we're using GraphRAG to power our provider coach, I guess is the best way I can call it that. So when we chat and interact with patients, and I wish I could do a demo of this, but I'm not allowed to show that part of it right now because of HIPAA reasons. When we have a chat that providers interact with in HIPAA compliant way to chat with their patients, as well as video chatting. So they chat in Google Meet. We have a plugin that extracts the audio, transcribes it. Either case, as the agent is receiving the text and going through that, it is taking the utterances, running a classifier over it, extracting anything useful, and then it is performing a GraphRAG lookup against both the patient's past history, the things we've talked about with them, as well as their medical file, as well as any other information. We sometimes have as much as 10,000 pages of documentation from other clinics about our patients, and we've indexed and sorted all that. And the way it optimizes insulin management is it provides actionable insights to our providers in real time. Well, when I say real time, in the flow of conversation, maybe 30 seconds, maybe 45-second delay to do all that, but it provides them in a side panel view saying, note, this person just mentioned that they had trouble catching the bus. Here's where they live. Here's the bus routes. This person said that they have nothing is wrong with them at home, but they've also mentioned their dog died. Maybe you want to ask them about that. Maybe you want to ask how they're feeling tomorrow. That's an example of that transactional analysis engine that I was referring to is implemented using GraphRAG, graph technology, that is optimizing the insulin management, because we're humans. We're not just one thing. We're not just inject ourselves with insulin and we're all better. We have emotions, we have feelings. Those feelings change. We can't control our feelings, but we can help reinforce how they respond to their feelings, good or bad. And those feelings, the responses, drive their compliance with insulin management and with their health. So by providing the providers tools to better understand their patients, their mental status, and what's going on in their life, have a more holistic view of where their patient is at, both in medical history as well as emotional state, we do optimize insulin management by optimizing the interactions for the providers.
Excellent answer, I think, Josiah, and definitely having health personalized would be cool. I mean, to have it ideally personalized would be really well, and so that there is a system that knows everything about you, and then it can impact your decisions regarding health. So that's a definitely great approach.
If you remember the slide that I was showing you earlier, that's why things are important to look at holistically, because it's expensive to get that type of behavioral care. But if we can enable a provider to do more of that more quickly without having to be an expert at every single patient, we can increase the number of patients the provider can help. We can increase the assistance we offer to the population. I know that I talked about talking about Monte Carlo tree search and POMDP. I am also aware that we're 4 minutes over, so I don't want to miss talking about something if somebody's super interested in that. But B, I'm also more aware of the fact that 45 minutes is a long time to listen to one guy run his mouth. And so I want to be respectful of people's times. If somebody wants to know about MCPS, speak up now, how we're using it. Otherwise, I want to give Katrina the floor.
I see Bassem is still typing. Oh yeah, he has a suggestion.
Yeah, we do have a number of different medical devices that our providers prescribe or suggest our patients to use, but none of them are reporting data back as quickly as we want. So in our practice, our patients monitor their insulin 5 times a day, and they report it to us up to 5 times a day as well through our portal that I've created that sits on top of Salesforce. We use Salesforce as our source of truth. Most of the needles that monitor insulin, they provide a dashboard that syncs to the medical practice that gives daily average trends, doesn't give us individual needle sticks. So, and right now we move fast with having people self-report, and that is another area that we're optimizing insulin management. If I can just geek out on this for just a second. Like my own mother, she is an incredibly smart woman. She is probably smarter than me. She hates computers. She hates smartphones. She'll tap on her tablet and then almost throw it across the room because it doesn't respond quickly enough. So she's a perfect target market, and I love her, and she is an amazing woman. So I don't mean that to diminish her as a person. It's just she doesn't like technology, much less my grandmother, who definitely didn't get technology. But that target market, that target type of person, they're going to struggle with diabetes, and to be able to get access to care quickly enough, because we have a technology platform that gives real-time access to their providers through chat and through reporting the insulin, and then through reporting their blood sugar, and then our providers will titrate that insulin as quickly as every day to every 7 days, versus here's your insulin prescription, come back and see me in a month type of a thing. So we're getting real-time feedback. However, if they don't like technology, if they're averse to entering data in an app, that's okay. Again, remember, we want to meet people where they're at, not have them comply with our ways of doing it. So to that end, we've stood up a voice AI agent that can provide access to the patient's chart for the patient to report their blood sugar and understand what their prescription was for that given blood sugar range, because every blood sugar has a different prescription, and that is not an AI generated thing. That is a read from the chart for this value, the doctor said this, and that is an exact thing that's not run through an LLM, so no hallucinations. And then also report back how they're feeling, and also ask to speak to a provider if they need to. And they can do that as from a rotary phone if they need to, a dumb phone, up to obviously a smartphone. So AI has enabled us to provide access in that way as well. And I see Marco's asking, how would I do this without graphs, just using GraphRAG? How less would the impact be? It depends on the specific case of what this is without graphs. Some things with GraphRAG is good enough for the use case, and can add less latency. When we're talking about retrieving multiple diverse hops of information from different parts of the data set, the GraphRAG graphs offer the advantage of being able to quickly connect the dots through the different topics, using the entities, using the vector lookup on the edges, and then finding those relationships very, very quickly. Whereas if I'm doing that purely with a vector database, I lose a lot of the context around the relationships between the chunks, as well as between the concepts. And I run the risk of having, at the top of a vector search result, for example, tons of chunks from one document, from one area, because that's a good match, without having the scope of the graph, where if I do a vector search against my graph edges, I'm likely to get from different parts of the graph a much wider view, a much lower entropy of the data set. So again, sorry, Marco, to give a very broad answer, but it does depend on the use case. So if I'm optimizing for giving multiple sets of data, like thousands of pages of medical charts, the graphs itself offer a better way of getting quicker access to the diverse information than if I just do a simple vector search. Vector search does have a place, and you can see I obviously use that in my stack. It's not necessarily an either or thing. They're complementary things. They're very useful things. For example, if I want to hop quickly from one edge of the graph to the far, far, far edge, I don't know what that edge is. I don't know what the name is over there. Vector search will get me there. Help say, hey, it's probably one of these 10 nodes. Then I can quickly look those nodes up and find neighbors from there. So it's a teleportation device if you want. But yeah, it has its use case.
It's like a guide through the labyrinth, like vector search,
yeah.
like how to get there.
Absolutely. I mean, this is I do have this up. Okay.
There is
labyrinth
another
is definitely
question as well, but yeah, you do you definitely.
No, this is the cipher docs, and this was the path it used to find an answer that I can't seem to find the output for, unless this is it. No, I so wanted to have that output up, but I don't have it. So when it did the GraphRAG earlier for a cipher question, it sent the path that it used, or the nodes that it found, up to my browser and highlighted those. So you can see that it highlighted
that's nice.
these edges for a cipher query. Sorry, do I provide explainability of the results of the GraphRAG by using knowledge graphs, and also justification for why this is the result? Do I provide explainability of the results using knowledge graphs? I'm not sure exactly what, I don't want to just gloss over this answer there. I'm sorry. I'm not sure how to say your name even. I'm sorry, Bloja. I apologize if I'm saying that wrong. Explainability to the results of the graph by using knowledge graphs. I'm not sure exactly how to answer that one. So I don't generally, when I'm providing Q&A type GraphRAG style, I don't typically say we use these nodes or these edges. That's useful for me debugging to look at what it actually used, but it's not something I typically provide to the user context, just because they wouldn't necessarily want to see the edges, wouldn't care about the edges, and yeah, that's not even what I want to see. Come on, people, get together. So to your point, no, I don't. As a developer, sure, I definitely want to inspect that, but not for the sake of the users typically. Single feature made me choose Memgraph, and the things I found interesting in the journey of using Memgraph. Wow, let us just really talk about how amazing Memgraph is. That's, I'll get back to you, Bassem and Bloja. Yes, how the AI gets the results. I do have a very, very hyperactive, picky, anal retentive CMO, Dustin. He is like, this doctor is like a hummingbird on crack. That's how I love him to death. He's a great guy, and he is always asking the hard questions, and he definitely wants to pick apart. How did you get this? I don't agree. I don't like that. Tell me how you did that. Typically enough to satisfy him is the citations that I give. So we found this answer from this document, this answer from this document. As far as single feature that made me choose Memgraph, what was the thing that you found interesting in your journey of Memgraph? The thing I found most interesting was the amazing documentation, the help that I got on Discord from it as a unified community. Obvious comparison was between Neo4j and Memgraph. Neo4j I likened to Jira. When I was trying to use Jira for project management, there were like 10 different versions, all saying 10 different things. How do you do epics? How do you turn epics on and off? Good luck finding the right document tells you what button to click, because this version may be 2 versions out of date. I've had a similar experience with trying to use Neo4j. I found it very undeveloper friendly. Well, they didn't have Precina. They're making life easier for developers. That's why. But obviously, it's been a better community experience, and it seems to be a more community-oriented project, and not just a community-oriented project, a very commercially viable project. And so both the open source nature of the easy to run, the access to information, as well as the documentation, made my entrance into Memgraph a lot easier. And as I was telling Katrina earlier, yeah, I keep turning on my Memgraph instances. I have Docker, I have a local instance I run, I have one in the Memgraph cloud, I have a couple in Kubernetes cluster, all for different test purposes. So I love the flexibility of being able to run it wherever I want to run it as well. It's been a wonderful experience so far. So yes, thank you to Katrina for all your hard work on the community. And with that,
thank you so much for the kind words, Josiah. It means a lot, especially for the whole, I think, developer experience team as well as Memgraph team. We do take care of those things, so it's nice to hear it's being noticed and important as well. We feel it's important, but it's nice to hear others think that as well. Yeah, definitely. I think this was a really nice presentation. Thank you, Bassem, as well. I know Bassem from the community, and this has turned into a really nice presentation. But yeah, thank you, everyone. Josiah, this was really good. I don't think we ever had this many questions, and it was really packed with knowledge. People were asking great questions. You gave great answers. And as Josiah says, he has a lot more knowledge to share about Markov chains as well. And he is part of our Memgraph community. So if you have more questions to him, you can also post your questions there on the Discord, and he'll definitely, I'll pin him where he'll see it. And yeah, I think we can wrap this up. Thank you, Josiah, once again for showing up, for doing this presentation, and we can bring you again when you have like 10 more use cases, or maybe you even improved your GraphRAG with new parts of the research, and you can tell us more about that.
Happy to share, and feel free to reach out to me in Discord. I'm on the Memgraph Discord server as well as tons of others. So thank you, Katrina, for making this happen.
No problem. Yeah, and anyone else who is trying to build a GraphRAG or anything, just let us know. We'll see what we can do, and we'd love to hear your stories. Maybe you have a totally different idea than Josiah, and I feel like everyone would like to hear about it. So let me know, and yeah, we can organize something like this again. Okay, that's it. Thank you. Bye. See you actually next week on another community call. And yeah, thank you for joining everyone, and bye.